Good morning, children. In previous class we have learned the electromagnetic induction. So based on this principle, the current induced is very small, and in order to produce the large amounts of energy, a conductor is allowed to place in a magnetic field which consists of a large number of turns, so that the induced current produced in the coil is, each turn of the coil is added up, so a large amount of electric current is produced. Such a setup is called an electric generator. An electric generator is working on the principle that the mechanical energy is converted into electrical energy. So, mechanical energy is provided to a generator by means of any external force, maybe water flowing from the high altitude, or steam, or the nuclear fission process may be used to generate steam to rotate the rectangular coil. So here the main parts of, let us see the main parts of an electric generator. So there are two permanent magnets are there. These two permanent large permanent magnets are placed. Okay. So the first parts, magnets and two. Then a rectangular coil ABCD is placed in between these two magnets, and which is connected to a shaft or connected to a rod, and then this is called an armature. And this coil ABCD is consists of large number of turns, which is mainly made by a good conducting material like copper. Then a large number of turns are present in this coil, and this coil is called as armature coil along the shaft. And then two terminals of this coil is then connected to two consistent brushes B1 and B2, and these brushes are then in contact with two rings, and these two rings R1 and R2, so that these two rings are externally connected to attach to the axle or the shaft, so that when the shaft rotates, the ring also rotates. Then brushes then connected to a galvanometer, and galvanometer picks the current or traces the current flowing through the circuit. So these are the main parts of the a electric generator. So in previous class we have seen that in the case of electric motor, there was only one ring which was half rings. One ring is made into half. This half rings they together we call a commutator, and this is also a commutator system that commutes the electric current, or that commutes electric current induced in the circuit. And when current is induced in the circuit and which flows through this coil, so it produces the electric current. So, and this shaft or axle is then connected to, or is exactly passing through the axis of this rectangular coil, and may be connected to a turbine. Okay, here and this turbine may be rotated by means of an external force like water, steam, or the nuclear force may be used to generate steam to rotate the turbine. When it rotates, this coil rotates, and when the coil rotates, the shaft rotates, then the spring rotates, then brushes come in contact with the brush rings, and then an induced current will be produced or may be traced by the galvanometer. So let's see how does it work. So when this mechanical energy is provided here to rotate the coil, and this mechanical energy, then the arm AB goes up and CD moves down. As it moves down, this side goes down. Then what happens? The brushes come in contact with the rings, and then brushes then connected to a galvanometer. So as the coil moves, there is a change. There is a change in the magnetic flux. Okay, so these magnets are producing magnetic field, and then when the magnetic field is there, and then this coil may be rotated or maybe change the it rotates or it moves in the magnetic field. So when a coil moves in the magnetic field, then there is a change in the magnetic flux, and that change in the magnetic flux will produce an induced current in circuit. And then that when it changes, okay, when it rotates, then induced current will be produced here when the brush is come in contact with the rings, and then an electric current, a small electric current will flow through the circuit. So the arm AB will go up, CD will go down, and there will be a electric current produced in the each turn of the coil added together, and it produce a large amount of current. Then once after the half rotation, so the arm AB will be this side and CD will be this side. So then again it rotates by the means of this external force. Then the direction of electric current will change. That means now the direction of electric current from D to C and B to A here. So after half of the rotation, the direction of electric current changed here. And now this direction of electric current changes, then here the direction of induced current produced also will change. Then that means after each half rotation, the direction of electric current flowing through the coil will change, so that the direction of induced current produced also will change. So this is why this alternatively taking place. That is why this current generated by an electric generator is called AC current. And also this commutator system, okay, carbon brushes and carbon rings, they are arranged in such a way that, for example, if you want to take out the current produced in this coil from these brushes or the rings to two wires to our home. So what will happen? As the axle rotates, then the wire also will rotate, because these rings are internally attached to the axle. Okay, when the brush is coming in contact with, then when they come in contact with, as it rotates, then the ring also will rotate. If the wires are connected to the ring, then what will happen? The wire will get twisted. Okay, the wire will get twisted. So if they are permanently fixed here, okay, and this commutator system does not allow the wire get strangled or get twisted, because due to the carbon brushes B1 and B2 here. So when it rotates, this brushes is come in contact with the brushes are kept here. When they press, and the brushes will come in contact with the rings. As it rotates, the brush does not move. Okay, and the axle will rotates, the brush does not move. The two brushes are like, okay, press one here, one here. So as it rotates, then brushes does not change its position, so that the wire is connected to take out the output does not get strangled. Okay, so this is how the functioning of a commutator system. So this is how the electric generator produces alternating current. That means each half rotation, the direction of the electric current induced in the circuit is changes. Okay, and we graphically already seen that. Okay, after the half rotation, this is the cycle produced, and the next half. So what happens? Then again, and the next likewise. Likewise, the electric current, the induced current changes its direction after each half rotation. That means its phase is changing. First, the positive half phase and negative phase, positive phase and negative phase. And this is why this current is called alternating current. And also, electric generators are of two types: AC generator and DC generator. So a DC generator produces unidirectional current. That means the current produced by an DC generator is always in the one phase only, like this. That means it always produce the current in the positive phase. Okay, that means this phase change does not take place in case of a DC generator. And how does it happen? This is because in DC generators, these two split rings are not there. The commutator system is made by two half rings. Okay, two half split rings. That means instead of these two rings, a single ring, two half rings are there, as seen in the case of an electric motor. So it does not change the phase of the electric current induced in the circuit. So such a generator is called DC generator, and this is called AC generator. And the direction of electric current induced in this electric generator, AC or DC generator, can be detected by using Fleming's right hand rule. So we have learned the Fleming's right hand rule yesterday. Okay, by using that we can find out the direction of the electric current induced in the circuit. The main difference between AC generator and DC generator is that the change in phase of the current. So an AC generator produces a phase change in the induced current, but a DC does not change its phase. So it is always flow in the one direction, unidirectional. But here the direction of flow of electric current changes after each half rotation. So the most power stations constructed in India using an AC generator to generate electric current. AC changes its direction after every 1/100 seconds. Therefore, the frequency of the current in India is 50 Hertz. 50 Hertz is the frequency of electric current in India. Another important advantage of AC generator over DC is that AC current can be transmitted over a long distance without much transmission loss. And these are the differences between AC generator and DC generator. I hope you understand.